Now today I am going to start intersection of two sets. Intersection of two sets means the common of both the sets. If set A is defined as 1, 2, 3, 4, set B is defined as 3, 4, 5, 6, then A intersection B is defined as common to both the sets, that is 3 and 4. When you go for Venn diagram, so first you make universal set, set A, set B, 3, 4 is here, this is set A, this is set B, 1, 2, 5, 6. A intersection B is equal to set 3, 4. Now, in set builder form, we can define A intersection B as set builder form. All x's that x belongs to A and x belongs to B. This is intersection of two sets. Now you take question on intersection. Question number 1. If A equal to 3, 5, 7, 9, 11, B equals to 7, 9, 11, 13, then find A intersection B. Now, for A intersection B, first you write set A, 3, 5, 7, 9, 11, intersection 7, 9, 11, 13. That is equals to 7, 9. This is the intersection of A and B. Another question. Question number 2. If A equal to set ABC, B equal to 5, B has no element, then find A intersection B. In intersection of two sets, if one set is an empty set, then their intersection is also empty. Now, A intersection B can be written as set this intersection null set, so that is equal to null set. You can show it by Venn diagram as this. This is your set A, its element are ABC. This is your set B. They are treated as disjoint sets and their common is again empty set. Now question number 3. If A is defined as all x such that x is equal to 3n, n belongs to Z, and set B is defined as all x such that x is equal to 4n, n belongs to Z, then find A intersection B. So in this case, what will you do? X belongs to A intersection B means x belongs to A and x belongs to B. You have to find out all x, that x belongs to A and B both. So what do you do? Let x belongs to A intersection B implies x belongs to A and x belongs to B both. This implies that x is equal to 3n, n belongs to Z, and x is equal to 4n, n belongs to Z. So in this case, this implies that x is equal to 12n, n belongs to Z. So here A intersection B is defined as all x such that x is equal to 12n, n belongs to Z. This is the intersection of these two sets. Now, intersection of three or more sets. Intersection of three or more sets. N is greater than or equal to 3. Intersection I varies from 1 to n. AI is defined as all x's that x belongs to AI. That is for x belongs to AI for each I. So that is, and I varies from 1 to n. You may see 1 is less than or equal to I is less than or equal to n. So in this way we are defining the intersection of three or more sets. Now properties. If you are set A, some question on this. If your set A is equals to question 5, if A equals to 4, 5, 7, 8, 4, 5, 7, 8, 10, B equals to 4, 5, 9, C equals to 1, 4, 6, 9. Then verify that. Then verify that number 1, A intersection B intersection C is equal to A intersection B intersection C. Second, A union B intersection C is equal to A union B intersection A union C. Third, A intersection B union C is equal to A intersection B union A intersection C. In this example, you have to verify these properties. These are the properties, you know. So now I am taking the first property. First, your LHS equal to LHS equal to A intersection B intersection C. That is, your set A is 4, 5, 7, 8, 10. Intersection B is 4, 5, 9. Then intersection C 1, 4, 6, 9. You may see your common element of these two sets are 4 and 5. 4 and 5. Intersection 1, 4, 6, 9. So that is equals to 4. So A intersection B intersection C, your LHS is this much. Now you find RHS. Your RHS equals to A intersection B intersection C. That is equal to set A 4, 5, 7, 8, 10. Intersection B 4, 5, 9. Intersection C 1, 4, 6, 9. You can write this is equal to 4, 5, 7, 8, 10. Intersection 4. 4 and 9. Now common of these two is again stringlet and set 4. So in this way you can observe your LHS and RHS are same. This is 2, this is 1. So from 1 and 2 you can say that A intersection B intersection C is equal to A intersection B intersection C. In this way your first result is verified. Now come to second. Similarly, you can do other questions. Do yourself. If you have any difficulty, you can ask that. Because you know how can you ask the question. I have already sent you a message and you follow that. Now properties of intersection. Properties of intersection. First property, A intersection B equal to B intersection A. This is called commutative law for intersection. Second, A intersection B intersection C equals to A intersection B intersection C. This is called associative law for intersection. Third, phi intersection A, null set intersection A is phi and universal set intersection A is A. This is the law of phi and universal set. Fourth is For any set A, A intersection A is equals to A, this is called idempotent law. Fifth, distributive law of intersection over union, union over intersection. So, A intersection B union C is equal to A intersection B union A intersection C. This is distributive law of intersection over union. Now sixth is again A union B intersection C, that is equals to A union B intersection A union C. This distributive law of union over intersection. So these are the properties of intersection. Disjoint sets, when they are non-overlapping and they have no common element, they are said to be disjoint sets. And in that case, in case of disjoint sets, I have already told you A intersection B is a null set. Now I am explaining you disjoint property and overlapping property. What are the overlapping? In case of disjoint sets, if you take your sets 1, 2, 3 and set B as 4, 5, 6, they are non-overlapping. Non-overlapping sets are disjoint sets. So you can show in this thing. This is your universal set, this is A, this is B, A has element 1, 2, 3, B has 4, 5, 6, they are disjoint, A intersection B is 5. In this case, A and B are disjoint, they are not joint. When the sets are not joint, they are called disjoint, they have no common element. They are also, this implies that A and B are non-overlapping. Non-overlapping. They are non-overlapping. And what are overlapping sets? And they have some common element, they are joint. When you take set A as 1, 2, 3, 4, set B as 3, 4, 5, 6. In this case, they are overlapping sets. You can show it by this is universal set, this is A, this is B. They have 3 and 4 as common, 1 and 2, 5 and 6. A intersection B is not equal to 5. Here, A intersection B is equal to 3, 4. This is not equal to 5. This implies that A and B are overlapping sets. They are overlapping sets. Now, question. Question. Which of the following pair of sets are disjoint? Following pair of sets are disjoints. First, A is equal to 1, 2, 3, 4. Set B is defined as all x such that x belongs to n and 4 is less than or equal to x is less than or equal to 6. This is your first question. Second question, set A is A, E, I, O, U and set B is C, D, E, F. Third question, A is defined as all x such that x is equal to 2n and n belongs to n. B is defined as all x such that x is equal to 2n minus 1, n belongs to n. So, you have to identify that which pair of sets are disjoint sets. Now first, for all that you may be aware with this thing, this fact, when you want to find out their union, intersection or anything, you have to write the given set in roster form, if it is not in roster form. So first set A is in roster form, it is 1, 2, 3, 4 and set B contains the element 4, 5, 6 and in this case when you find their intersection, common elements of both the sets, it is equal to 4. This is not equal to empty set. This implies that A and B are overlapping set. Hence, A and B are disjoint. They are overlapping sets, and overlapping sets are not disjoint sets. Therefore, A and B are not disjoint. They are not disjoint because overlapping sets are not disjoint sets. So in this case, in first question, they are not disjoint. Now come to the second part. What is your second question? Your second question, in set A, your elements are A, E, I, O, U and set B is C, D, E, F and their common elements A intersection B is again E, that is not equal to null set. It implies that A and B are overlapping sets. Overlapping sets are not disjoint sets, implies that A and B are not disjoint sets. Now, third part. In third question, when you write the elements of set A and B, in set A is set of even natural number. Third part. Set A is set of even natural number 2, 4, 6 and so on. And set B is set of odd natural number 1, 3, 5 and so on. They have no common element when you find their intersection. This is null set. It means they are not overlapping. Not overlapping sets are disjoint. So this implies that A and B are disjoint. When you get this condition, A intersection B is 5, then they are disjoint. When you get A intersection B is not 5, then they are not disjoint sets. You remember this thing. So I have taken one question with you. Difference of sets. Now, difference of sets. Now I am taking difference of sets. How can you define the difference of sets? difference of two sets A and B is denoted by A minus B or B minus A, and it is defined by A minus B is defined as all x such that x belongs to A and x does not belong to B. B minus A is defined as all x such that x belongs to B and x does not belong to A. Their union A minus B union B minus A is the symmetric difference of set A and B. This is called A symmetric difference B, and this is defined as A minus B union B minus A. So in this way I have given you three definitions. Difference of sets A and B is defined as A minus B B minus A, and their union is the symmetric difference of set A and B. Now question. Again I am taking question. If set x equal to ABCD, set y equals to F, B, D, G, then find first x minus y, second y minus x, third x intersection y. You have to calculate these three things. Now I see that for x minus y, you write set x A B C D minus F B D G. In this set x minus y consists of those member of x which are not the member of B. A is member of x but A is not member of y. A is member of x but A is not member of y. So this is the member of x minus A. B is member of x but B is also member of y. So B is not the member of x minus y, because definition of x minus y is x minus y consists of those member of x which are not the member of y. So first element is A, B is not. C belongs to x but C does not belong to y, therefore C. And last D belongs to x and D belongs to y both, therefore this is not the member of x minus y. So x minus y is AC. Your x minus y is AC. Now second, this is your first. Second, y minus x. Y minus x, you write set y F B D G minus x is A B C D. Now in this y minus x, this consists of those member of y which are not the member of x. So f is member of y but f is not member of x, so it is the member of y minus x. B at both the places, so it is not. D at both the places, so it is not. So G belongs to y but G does not belong to x, so therefore member of y minus x is taken as G. From these two questions you can observe that your x minus y is not equal to y minus x. Now next thing you have to calculate in third part, you have to calculate x intersection y, means the common element of x and y. Common element of x and y is b and d. So x intersection y is b and d. So that's all about this. Now another question. I have already defined symmetric difference. So I am taking one question on symmetric difference. Question. If set A equal to 1, 3, 5, 7, 9, set B equals to 2, 3, 5, 7, 11, then find A symmetric B. So as you know that, we know that A symmetric B is equals to A minus B union B minus A. So you find A minus B. Your A is 1, 3, 5, 7, 9 minus B is 2, 3, 5, 7, 11. So A minus B consists of element 1, 2 is not here, 3 is here but 3 is also here, 5 at both, 7 at both, 9 belongs to A but 9 does not belong to B. So A minus B is 1, 9. Now find B minus A, that is equals to, your B is 2, 3, 5, 7, 11 minus A is 1, 3, 5, 7, 9. 2 belongs to B but 2 does not belong to A. So therefore B minus A consists of 2, 3 and 5, 3, 5, 7 is here and there both. 11 is here but 11 is not there, so 2 and 11. Now you can calculate asymmetric B, that is A minus B union B minus A, that is equal to A minus B is 1, 9 union B minus A is 2, 11, that is equal to set 1, 2, 9, 11. So this is, in this way we can find asymmetric B. Complement of set. Another topic is complement of a set. Complement of a set. Let U be a universal set and set A is subset of U. Complement of set A is denoted by A dash or A to the power C and defined by A dash equal to, this is defined as all x such that x belongs to U and x does not belongs to A. Those member of U which are not the member of A is the member of A complement you can define A complement in the sense of difference of sets as universal set minus set A. Means those member of universal set which are not the member of A are the member of A complement. Now question. You take question. If universal set U equals to 1, 2, 3, 4, 5, 6, set A equal to element 2, 4, 6, then find A complement. You can write, we know that A complement equals to U minus A. Your U is 1, 2, 3, 4, 5, 6 minus A is 2, 4, 6. Now you observe those member of U which are not the member of A. So 1 belongs to U, 1 does not belong to A. So first member of A complement is 1. 2 is not 3. 4 is not 5. Because 2, 4, 6 is present in universal set and A both. So therefore that is 2, 4, 6 is not the member of A complement, and remaining element of universal set 1, 3, 5 are the element of A complement. Now we reach about the some properties of complement. Properties of complement. Properties of complement of sets. First, A union A dash is equal to universal set, and A intersection A dash is null set. This property is called complement laws. We know this property as complement laws. This is complement laws. Now, higher definition. In this we are taking De Morgan's law. In De Morgan's law, what we are doing, A union B complement, this is union, A union B complement is A complement intersection B complement, and A intersection B complement equal to A complement union B complement. Union and intersection are changed. This is called De Morgan's law. Now third is complementation, double complementation. This is known as law of double complementation. Suppose you are taking complement 2 times, so that will give the same set A, that is called the double complementation law. And now laws of empty set and universal set. Last is law of empty and universal set. So complement of empty set is universal set, and complement of universal set is empty set. So this is called the laws of empty and universal set. Now I am doing some properties of application of sets. By that formula we find the number of element in A union B, A intersection B. By the given word problem of the question. So, first I am writing the formula in number of element in A union B. Number of element in A union B when A intersection B is not equal to 5. It has some element. Number of element in A intersection B is there. So in this case, number of element in A union B is number of element in A plus number of element in B minus number of element in A intersection B. If number of element in A intersection B is not equal to 0, implies that A intersection B is not a null set. It has A and B, common element of A and B. There is some element. Now, second result. Number of element in A union B is equal to number of element in A plus number of element in B if number of element in A intersection B is 0, means A and B, this implies that A and B are disjoint sets. They are disjoint, they are not overlapping sets. Now, third, the same property for 3 sets. For 3 sets A, B and C. Number of element in A union B union C is equal to number of element in C minus number of element in A intersection B, B intersection C, C intersection A plus number of element in A intersection B intersection C. With the help of these formulas, we will solve the practical problem. Now, some question on complement of a set. Question. Let universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A equal to 1, 2, 3, 4. Set B equals to 2, 4, 6, 8. Set C equal to 3, 4, 5, 6. Find number 1 A complement, 2 A intersection C complement, 3 complement of complement A, and 4 B minus C complement. You solve this. Now see, A complement is defined as U minus A. Those member of A which are not the member of, those member of U which are not the member of A. 5, 6, 7, 8. That is equals to 5, 6, 7, 8. In A complement consists of those member of universal set which are not the member of A. That is the member of A complement. This is the first part. Now second part. First you find, in order to find A intersection C complement, first you find A intersection C. Your A is 1, 2, 3, 4. Your C is 3, 4, 5, 6. Now A intersection C is 3, 4. Now A intersection C complement is equal to U minus A intersection C. Those member of universal set which are not the member of A intersection C. So means in A intersection C there is the element 3, 4. You make out from universal set. So remaining are the element of A intersection C complement. So in this way your elements are 1, 2, 5, 6, 7, 8, 9. This is the member of A intersection C complement. Now third is, in third, complement of A is this, so you find its complement, that is equal to the set A by the property. This is 1, 2, 3, 4. In fourth, first you find B minus C, then you find, in fourth part, first you find B minus C. Your B minus C is equal to set B 2, 4, 6, 8 minus C 3, 4, 5, 6, that is equal to 2, 8. Now B minus C complement equal to universal set minus B minus C. In B minus C there are two elements 2 and 8, and you take out from universal set 2 and 8 and write all the remaining elements, and that are the elements of B minus C complement. You make out 2, 8, delete 2, 8 from universal set and write the remaining element. 2 is here, 8 is there, you delete that. So your element in this set is 1, 3, 4, 5, 1, 3, 4, 5, 6, 7, 9. This is the element of B minus C complement. One thing I forgotten, and that is the formula for number of element in A minus B and number of element in B minus A. So number of element in A minus B can be defined as number of element in A minus number of element in A intersection B. Number of element in B minus A is number of element in B minus number of element in A intersection B. These are the two formulas, you remember that. Now I am taking some mixed problem. My question: if A is defined as all x such that x is equal to 4n plus 1, 2 is less than or equal to n is less than or equal to 5, n belongs to n, the number of subsets of A is, then the number of subsets of A is A 8, B 15, C 4, D 16. As you know that 2 to the power n is the number of subsets of the set A if A consists of n elements. So how many elements are how many elements are there in the set A? You take the values of n is taken from 2 to 5 including them. So 2, 3, 4, 5. There are 4 elements in the set A. So 2 to the power 4 is the number of subsets. By that definition, your answer is D. Now, if A and B are two sets, then prove the property of commutative law for union and intersection both. For two sets A and B, question. If A and B are two sets, then prove. First, A union B equal to B union A. Second, A intersection B equal to B intersection A. These are the commutative law for union. This is commutative law for union, and this is commutative law for intersection. So first, let X belongs to A union B. Then this implies that X belongs to A or X belongs to B. When you change their orders, X belongs to B or X belongs to A, this implies that X belongs to B union A. Here you have the result X belongs to A union B implies X belongs to B union A. By the definition of subsets, you can write A union B is subset of B union A. This is your result number 1. Similarly, let Y belongs to B union A implies that Y belongs to B or Y belongs to A implies that Y belongs to A or Y belongs to B implies that Y belongs to A union B. Therefore, B union A is subset of A union B. This is 2. As you know that two sets A and B are said to be equal if A equal to B. As you know, A equal to B implies that A is subset of B and B is subset of A both. So by this, from 1 and 2, we can write, we get A union B equal to B union A. In this way, you have proved commutative law for union. Similarly, you can prove this result for intersection. Now second part. Let X belongs to A intersection B implies X belongs to A and X belongs to B implies that X belongs to B and X belongs to A. This implies that X belongs to B intersection A. By the definition of subsets, A intersection B is subset of B intersection A. Similarly, you can prove B intersection A is subset of A intersection B. This is 1, this is 2. From 1 and 2, we can write A intersection B equal to B intersection A. This is the commutative law for intersection. Now, if ABC are three sets, then we will prove associative law for union and intersection. If A, B and C are three sets, then prove number one. A union B union C equal to A union B union C. Second, A intersection B intersection C equal to, this is associative law for union. This is associative law for intersection. First, let X belongs to implies that X belongs to A union B or X belongs to C. Implies that X belongs to A or X belongs to B or X belongs to C. Implies that X belongs to A or X belongs to B or X belongs to C. Or is it everywhere? That's why you can change the clubbing. X belongs to A or X belongs to B union C. Implies that X belongs to A union B union C. By the definition of subsets, you can write A union B union C is subset of A union B union C. This is your result number one. Again, let Y belongs to A union B union C. This implies that Y belongs to A union B union C. Therefore, A union B union C is subset of this. This is 2. So from 1 and 2 we have this result. So in this way you can prove the associative property for intersection also. So that's all for today. Thank you.